flow net is a graphically representation of two-dimensional steady-state groundwater flow through aquifer, as well as the use of the collection soils particles we call soil grains, deposit soil mass, and closes empty space what you call void, and the movement of the water to the soil is called seepage. It's graphical. As you can see, there are shape pile and there are soil of the thickness, and both sides have water. If we get the flow, we get design quantities. We use graphical methods commonly. It is because of easy and accurate this method of solution Laplace equation. On other side have depth water big letter D, and other side depth water small letter d. As you can see, the imbalance of head of the different side shape pile, so the water high head to low head, but water cannot pass for the shape pile, so flowing take place through seepage. The soil below it as considered water molecules by upstream surface goes a little tip and down the surface and what you call flow line, and then many particles downstream. So the flow path, similarly many particles upstream rise the downstream different flow lines noted. Each flow line they came from upstream surface, which is add pressure gamma, the big capital D, and travel the lost soil constantly losing each energy, and dominance the downstream surface, which is added pressure gamma, the small capital D. So they can pick up certain point in different flow lines that total energy loss is equal or use same energy level. And then they join the point together, the lines so form equipotential lines. Similar different parts save energy. Flow lines can be observed and many such equipotential can be drawn. So if you insert piezometers on different forms along equipotential line, you will notice the water rises are the same relation of then you can have received flow net, and this between edges of flow line is called flow path or flow channel, and the area of the two edges of flow line and equipotential line is called flow field. In the flow net, they can drop many possible flow lines and equipotential line, but first it is very inconvenience to drop full many of these lines, and second, too many line does not increase accuracy and calculation, so only 4 or 5 each should. To draw meaningful graph, we need to keep in mind certain characteristic of the flow net. First, flow line never cross each other because flow line in soil world is considered laminar. Similarly, equipotential line never cross each other because they cross any points, then the total head under point they will be to lose, which is not possibility. And second, characteristic of flow net, the flow lines and equipotential lines are orthogonal to each other. That means they should intersection each other at right angles. The ratio of the length they top each flow field should be constant. Generally, the ratio is for convenience. In other words, the flow net consistent approximately this square they called elementary squares. Elementary squares, every distance, the gain opposite side are equal. To construct a flow net, they also identify the presence to the flow boundary conditions. The boundary conditions are restriction, limit the flow to a certain space. A flow net is unique to boundary conditions. If the geometry of the flow is changed, the boundary condition will be changed, and hence the flow line will be changed too. Purpose, the boundary condition is the upstream surface from their flow. Stop if you don't notice. The first equipotential line of our flow net is every point of this line, the total head is same. And second boundary condition, the downstream surface in the last equipotential line of all flow net, the tear bound condition is shape pile. Water molecules cannot cross the shape. If flow from this point the vertical downward, and after process ship pile, it is vertical upward. The ship pile tracing also the flow path molecules. So this boundary tells ABC is the flow line, and the fourth boundary is impermeable surface. The water molecules cannot cross it. This is also flow line. Is the water flow along this surface from left to right while doing flow net. This keep in mind that no flow line can intersect the impermeable boundary. While in drawing the flow net, keep your mind that there are flow line cannot intersect the impermeable boundary H itself flow line. The same reason potential line must be are the right angles because impermeable boundary are flow lines and flow line with equipotential line on right angles. And drop of head between the two edges, the two adjacent is constant. It means if the head of first equipotential line is 15 meter and after pass of equipotential line, that head is traveled by 2 meter, so round of head should also be 2 meter and so on until to the last equipotential line, as you can see in the diagram. And also the discharge between two adjacent flow channels is constant. Until we discuss the graphical method of flow net, we will be calculate the slippage into the soil. Let's see height of this flow field small a and length small b. We know that Darcy's law, the flow rate is equal the K permeability of the soil. A is the area of cross section through which the water is flowing, which is the height field is A W, but the general is equal to I meter, and is hydraulic gradient vector lead loss or the length of flow. Field pressure drop, say delta H. So discharge this flow field is this. Now delta H is the head loss of this field or potential drop, and there are number of drops is ND and total potential drop or head loss. Substitute in the equation to find discharge through a flow channel. So as you can see, this one potential drop between equipotential line and this two potential drop between three potential line, and ND is a number of equipotential line minus 1. This discharges one flow channel and total number of flow channels are in left and total discharge. And remember the flow net contracted elementary squares. The quantities of A over B is 1. So total discharge also can be written this. This is called shape factor. It is depend to the boundary condition.